Greetings, math fans. All right, so this is day 2 of our counting unit, and basically we've already learned yesterday about the slot method. We're going to kind of expand on that a little bit. All right, so today's topic is called mutually exclusive events, and you got some words here in front on this note sheet. But let's just talk a little bit about a mutually exclusive event. It's an event that can't happen at the same time. And I even put here an example is rolling a 5 on a die and also rolling a 6 on a die. You can't roll a 5 and a 6 on with the same roll on one die. Okay. Another example would be drawing a queen and an ace in one draw from deck. There's no queen ace card, right? It's just a queen or an ace. And then I put here as an example of non-mutually exclusive events would be like drawing a queen or a heart, because you can draw a queen of hearts, right? You can't that can happen at the same time. So we call that mutually inclusive. Actually, it's the word for it, and that's again where you can do something where it can happen at the same time, like a queen of hearts or two of diamonds, right? So anyway, it says if two events are mutually exclusive, then we're going to use something called the alternative case principle. Basically, we're going to get to an example here in a second here, but if an action can be analyzed into several cases, mutually exclusive, that events that can't happen at the same time, basically what you're going to do is you're going to figure out how many ways something can happen for case 1 and case 2 and case 3, and then you're just going to find the sum of those. You're going to add those together. Okay? So let's just kind of look at our first example here. It says, using a set of digits 5, 6, 7, 8, how many numbers can be formed if digits are not repeated? Again, it's something you have to look for all the time. Is it repeated? Is it not repeated? And this is a key word here too, math fans, so we're going to highlight this. So this guy right here, how many numbers can be formed? Now yesterday, in day 1, we basically, you just said how many ways can you organize. So in other words, I said it was a 5-digit number or a 4-digit number, and you drew 4 slots or 5 slots, you drew that exact number. Now I'm just saying, hey, how many numbers can be formed? So in other words, I can use one of them or 2 of them or 3 of them or 4 of them in this case, right? Because I'm setting, I'm giving you 4 different digits. So I kind of broke this down here, the solution. I even said it's necessary to count the number of single-digit, 2-digit, 3-digit, and 4-digit numbers. Again, this is different from yesterday, because yesterday's the directions were literally I said how many 3-digit numbers can be formed, and you drew 3 blanks. This doesn't say 3-digit numbers, it says how many numbers. Really, really important that you guys recognize that, okay? So if you look how many single-digit numbers, well, there are 4 numbers, because I can put 5, 6, 7, or 8. Okay, and again, remember, this is key here, not repeated. So how many 2-digit numbers? Well, the first digit, there's 4 possibilities. I use one of them, so how many do I have left? I have 3 of them left. Okay, and we're using the word "and" here because it's we have 4 digits and then 3 digits, so I multiply this together, so I get 12. And then for a 3-digit number, okay, kind of the same thing, right? You're saying I've got 4 to start with, I use 1, I've got 3, I use another one, I've got 2, so multiply that together, I get 24. And then for a 4-digit number, you got 4, then 3, then 2, and then only have 1 left at the end, so that's actually 24 as well. So the total number of numbers, and what we're going to say is if I'm adding all these up, I either have a single digit or a 2-digit or a 3-digit or a 4-digit. And remember, guys, OR means add, and means multiply. Really, really important. Okay? So it's a 1 or 2 or 3 or 4 digits. So that's why I have 4 plus 12 plus 24 plus 24, which gives us 64. Okay? So there are 64 ways that you can form digits from those numbers. Okay? So again, you got to understand the difference between how many numbers and how many 4-digit numbers. Very, very important. Okay, so let's continue on here. Example 2, you roll 2 dice, and how many ways can you roll the 2 dice with the sum of the exposed faces? So here's the deal, math fans. Whenever you have a dice problem, you're rolling 2 dice, okay, you need to make a dice chart. I call this a dice chart. I'm not sure if anybody else calls it that, but it's a dice chart. It's really easy to make this. Basically, on the top row here, I'm going to put 1, 2, 3, 4, 5, 6. Those are the possibilities. And then going down the column, 1, 2, 3, 4, 5, and 6. So in other words, if I roll a 1 and a 1, I get a 2. If I roll a 1 and a 2, I get a 3. A 1 and a 3, I get a 4. 1 and a 4, I get a 5. 1 and a 5, I get a 6. And 1 and a 6, I get a 7. So this dice chart is actually the sum. It's the sum of rolling 2 die. Okay, or 2 dice. So I know kind of you're like, oh, I got to make this chart. It's actually really easy because if you notice, I wrote 2, 3, 4. So I went 1, 2, 3, 4, 5, 6, 7. The next row is going to be 2, 3, 4, 5, 6, 7, 8. The next one's 3, 4, 5, 6, 7, 8, 9. So I just kind of keep going. It's really easy to draw it. And 7, 8, 9, 10, 11, and 12. Okay? Great chart to draw because then when you're asked questions, you can just like do some counting and then you're kind of good to go. Okay? So the first thing is how many ways can you roll a die? So the sum of the exposed faces, and again, the sum, that's why we're doing a sum, the sum for this one, is less than 4. Well, that's all you do is you just count them. So if it's less than 4, it's the only possibilities that are less than 4 are these 3 guys here. So the answer is 3. Okay? The next one is an odd number. Well, I could count all the odd numbers. I can go the 3s and the 5s and the 7s and the 9s and the 11s, and that's fine. That's good. Okay, but recognize that aren't half of them odd and half of them even? Just a little, trick to kind of go a little bit faster here. And if you count right there are 36 possibilities, so I can do 36 over 2, which is 18. That's my answer for this. Or again, I can't count all the individual numbers. Okay, letter C. Is exactly 5, 12, or 13. So you're going to count the number of 5s. You're going to count the number of 12s. And there is no 13. So this, if I would count the 5s, I get 4 5s. Count the 12s, I get 1. And there are no 13s. All right, because you can't add, there's nothing bigger than 12. So if I add those together, 4 plus 1 plus 0, I get 5. Okay? Really pretty easy. Okay, so I've got some practice problems here. Using the set of digits 2, 3, 6, 7, 9, and allowing repetition. Again, make sure you guys look at what I'm giving you or what I'm telling you to do. Allowing repetition, find the number of numbers less than 1,000. Remember, this is not a 4-digit number or specifically a 3-digit. It's less than 1,000. So that means it could be 999, 990. In other words, it can be less, it's 3 digits, 2-digit, or 1 digit. So that's what I'm going to do. I'm going to draw 3 slots, 2 slots, or 1 slot. 3, 2, or 1-digit number. Okay, again, repetition is allowed. So I have 5 numbers here. I have no restrictions. It just has to be less than 1,000, which that's why we did 3 slots, 2 slots, and 1 slot. So it's basically, I can use every number because there's no, or I'm allowed in repeats, so I can use every number each time. Multiply that out, I get 125. Okay. Again, this is 5 and 5 because it's a 2-digit number. There are no restrictions, so I get 25. And then I can use all 5 numbers here, and I get 5. So if I add all these up, I get 155. Pretty easy. Okay. The next one, the number of odd numbers less than 100,000. So again, it's going to be 1, 2, 3, 4, 5, right? 5, it's in the 10,000s basically, and then you have the thousands, the hundreds, the tens, and the ones. Now the only issue I have here, math fans, is this right here, the number of odd numbers. All right. So in order for it to be an odd number, what has to be true? Do you guys agree that this needs to be odd? Right? That last number has to be odd in order for it to be an odd number. Okay? So if you look at our numbers, we have 2, 3, 6, 7, 9. The only odd numbers we have are 3, 7, and 9. There are only 3 possibilities. So that means this last slot is going to be a 3 for all these because they have to be odd numbers. That means that last number has to be it can be only a 3, a 7, or a 9. Okay? And then what can all the rest of them be? All the rest of them are all 5s because again it's all repeats, but there's no restriction for any of the other numbers. Okay? So the top number gives me 1875, 375, 75, 15, and 3. And if I add these up, I get 2,343. Okay, not bad. Okay, the next one is the number of even numbers having an odd number of digits that are less than 100,000. So like before I did 5 slots, 4, 3, 2, 1, but now it's saying I have to have an odd number of digits. So it's going to be 5 slots, 3 slots, or 1 slot. Okay? And then it's an even number. So again, if I look at my numbers here, an even number is going to be only a 2 and a 6, or only 2 possibilities. So kind of like I did with letter B, this is going to be 2 possibilities. Got to be an even number. And then of course, what are the other numbers? Well, you're allowed repeats, so these are all 5s. Okay, so I multiply the top one, gives me 1250. This one gives me 50, and this is of course 2. And I add these up, and I get 1302. Okay? Not too bad. But again, make sure you're good with, if I ask you for numbers less than it, you actually give me all the numbers, as opposed to if I just said, hey, give me a 5-digit number, literally you would just give me this one and that would be it. So understand the difference between the two. Okay? All right. So let's move on. This next example here is a dice problem. So if you're using your iPads, you can just cut and paste your dice chart, or you can actually draw it again. It doesn't take very long, but I'm going to draw it again. So you get 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, and 7, 8, 9, 10, 11, 12. Okay, good. So in rolling 2 dice, and how many ways can you roll a pair of dice so that the exposed faces have a sum which is an even number greater than 4? Well, again, you're just counting, right? An even number greater than 4, you're going to either roll a 6, an 8, a 10, or a 12, right? One of those 4 possibilities. So I count the number of 6s. There are 5 6s. And I count the number of 8s. There are 5 8s. Count the number of 10s. There are 3 10s. Count the number of 12s. There's 1 12. So I wind up getting 14. Pretty easy. Have a sum of 7 or 11. Again, you count the 7s. There are 6. So this is 7 and 11. There are 6 7s. And there's 2 11s. So there's 8 possibilities. Pretty easy. Have a sum which is greater than 7. Again, you just count them. Count the 8s and the 9s and the 10s and the 11s and the 12s. Again, it's really pretty easy. So there are 5 8s. There are 4 9s, 3 10s, 2 11s, and 1 12. And I add all of them together and I get 15. Okay, really pretty easy. All right, D, doubles. Now some of you guys might not know what doubles are. If you've ever played Monopoly, you know what doubles are. Doubles are, you get 2 1s or 2 2s or 2 3s or 2 4s or 2 5s or 2 6s. So it's getting the same number on both die. That's what doubles are. So if you get doubles in Monopoly, you get to go again. If you get 3 sets of doubles, you go to jail. How do you get out of jail? You roll doubles again. Okay? Doubles are a big part of Monopoly. It's a good thing. All right. So anyway, I mean, you can just look at it. I can just kind of highlight this here. The only doubles, right, are this guy right here going down there. So it's either getting 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, 2 6s, and that means there are 6 ways of getting doubles. Have a sum that is less than 13. Well, if you look at the chart, aren't they all less than 13? So that means they're all 36 are less than 13. And have a sum greater than 12. Well, there are none of them. So it's 0. Okay, the last one here is one die is 2 greater than the other. So what's saying here is basically when I roll a die, that has to be 2 numbers greater than the other. So I'm not really looking at the sum now. I'm actually looking at just the dice chart in general here. So let's take a look at the dice chart. So basically, if I roll a 3 and a 1, 3 and a 1, one die is 2 bigger than the other. So let me highlight this. I can roll a 3 and a 1. I can roll a 4 and a 2. I can roll a 5 and a 3. Or I can roll a 6 and a 4. Do you guys agree that one die is two bigger than the other? Well, let's come from the other way now, and let's say, how about if I roll a 4 here? So on the top, I'm on the top here now on this guy. If I roll a 4 and a 2, right? A 4 and a 2 would give me this guy right here. And what else? How about a 5 and a 3? That's good. And how about a 6 and a 4? Oh, and I missed the first one here. Gosh, why did I do that? A 3 and a 1. You guys agree? Those possibilities give me where one die is two less than the other. Okay? So if I count all those up, it's 8. It's pretty easy to do that. Okay? So the answer to this one is 8. So again, if I were just kind of writing it out, as opposed to even looking at the dice chart, you could say, oh, two greater than the other. Well, I can get a 3 and a 1. I can get a 4 and a 2. And I can get a 5 and a 3. And I can get a 6 and a 4. And I can also get, again, this is kind of the other die, the other, just flipping around, I can get a 1 and a 3. I can get a 2 and a 4. I can get a 3 and a 5. And I can get a 4 and a 6. Now, some of you guys might argue with me and say, well, wait a second, Mr. Curvis, isn't a 6 and a 4 the same thing as a 4 and a 6? Yeah, that's true. But it's kind of like saying, well, how many ways are there to get a 7? Do you guys agree? In order to get a 7, I just basically I can rule. There are 1, 2, 3. There are 6 ways to get a 7. You don't just say there are 3 ways because I can roll a 1 and a 6 and a 6 and 1. So truly, in this chart of 36 possibilities, there are 6 ways I can roll dice to give me a 7. Not just 3 ways. Not just saying 1, 6, 5, 2, 3, 4. I can also do the, where the dice are flipped. Okay, so I can do 1, 6. 2, 5, and 3, 4. Right? I can flip it around. Okay, so that is basically talking about die, and this is most of them are sum, but like I said, letter G is actually looking at the specific die. Okay, let's go on to the next one here. Numbers are to be formed using all 10 digits. So again, numbers are formed. So and then it says a 3-digit number for this first one. So if it's a 3-digit number, do you guys agree that I'm drawing 3 slots? Right? So 1, 2, 3. Now here's the deal. This is key. Without repetition, and I have all 10 digits that I'm using, 0 through 9. Okay? So I'm telling you it's got to start with a 1. So if it's got to start with a 1, that means there's only one possibility here. That 1 does not represent the number 1. It represents there's only one possibility. In other words, I could have done this exact same problem, but I could have said 5. Because it's got to start with a 5. It would still be a 1 there because there's only one 5. Okay? All right. So anyway, there's let's get rid of this here. There is 1, 1, and then I can't use numbers. There's no repeats, so there's, instead of being 10 numbers, there's 9 now. And then I use another number, and there's 8. Okay, because again, there is no repetition. So if I multiply that out, I get 72. So what I like to do here, math fans, I like to fill in my most restrictive spot first. So this one is the most restrictive. Because I'm saying, hey, it's got to start with a 1. Okay? Let's look at the next one. It's a 3-digit number again, so 3 slots. Numbers can't begin with a 0. It makes sense that numbers can't begin with a 0 because you don't go like to the movies, and if it's PG-13, they say how old are you, and you go, oh, I'm 014. Okay, you don't do that. You say, oh, I'm 14. You don't say there's no 0 in front, right? You don't say I gotta say a 3-digit number or a 4-digit number. I'm 0014. You say 13 or 14. Okay, so if it can't begin with a 0. There's 9 possibilities here. Again, this is my most restrictive spot, so restrict. This is my most restrictive spot. So it's 9. Now, what happens with the next slot? Do you guys agree? There's no repeats, but what happens to the 0 now? I can put the 0 back into play. I know I didn't use it for the first spot, right? So let's say I use the number 5 for the first spot. The second spot means, okay, I can't use 5, but now 0 is back into play again. So I really have 9 numbers again. And then what happens? Well, I use another number, and now I have 8. Okay? And so if I multiply that out, I get 648. That's important. Numbers can't begin with a 0. All right. Letter C, a 5-digit number ending in 0. So 5-digit number. If it ends in 0, that's my most restrictive spot. So that's what I'm going to fill in. So if it's got to end in 0, there's only one possibility. It's got to end in 0. There's 1. So I come back to the first number. Well, I don't have to worry about the 0 now because I just used it, didn't I? So how many numbers do I have left? 9. And then, of course, I have 8, and then 7, and then 6. Right? And so I multiply all that out, and I get 3,024. Okay, letter D, an even 5-digit number that does not end in 0. Okay, so even 5-digit number. It doesn't end in 0. That means I go to my last slot, and if it's an even number, do you guys agree it's either got to be 2, 4, 6, or 8? So there's only 4 possibilities here. Again, my most restrictive spot is right there. And so I've used either 2, 4, 6, or 8. I come to the first spot. So let's just say I use the number 2, and that's out of here. If I come to the first spot, I can't use the 2, and what else can't I use? Can't start with a 0. So there's only 8 possibilities here because there's no 0 there. I go to the next, so let's say I use the number 5. I come to the next spot. How many numbers can I choose from now? Well, do you guys agree? I've used the 2 and the 5, but what happens to the 0? Well, it comes back into play now because I can use it now. It just can't be that first spot. So now there is still back to 8 numbers, right? And then, of course, you just keep going down now. 7 and then 6. And if I multiply all that out, I get 10,752. All right. Okay, so letter E is saying an even 5-digit number. And it says, hint, think about letters C and D. I don't want you guys to write anything down now. I just want you guys to pay attention here because this is something you just need to watch, okay? So if I draw a 5 slots here and I say, well, it's got to be an even 5-digit number. Do you guys agree the last slot it can either be 0, 2, 4, 6, or 8? So there's 5 possibilities here. I come to the first slot. Here's the problem. Did I use a 0 here? So for this spot right here, did I use a 0 or did I not use a 0? Because if I use the 0 here, I would put a 9 here, right? Because then I don't have to worry about the 0. It's 1 through 9. But the deal is and that's if I use the 0 here. So if I use the 0. If I didn't use the 0, let's say I use the number 2, doesn't that really say, well, I used the 2 and I can't have a 0, so it really is an 8 here? So I have a dilemma, right? Did I use a 0 or did I not use a 0? So the reason I said think about letter C and D, letter C and D says it's a 5-digit number ending in 0, which is an even number, isn't it? If it's ending in 0, isn't even? And this one's an even 5-digit number, not ending in 0. So you're either going to end in 0, so end in 0, or not end in 0. So what does that mean? Well, it either ends in 0, which is the letter C, or not end in 0, which is the letter D. And what does or mean? Add. So it's one of 2 cases. It's either end in 0 or not end in 0. That's why I add these together, and that's how you do that problem. So basically it's 3,024 plus 10,752. Okay, you add those 2 possibilities. And if you add those together, you get 13,776. That's your answer. Guys, you need to put like 18,000 stars around this problem because that is such an important problem. All right? You will see this problem on the quiz. You'll see this problem on the test. You'll see it on your homework. Okay, you have to know when you see a thing that says a 5-digit even number, you have to know to split it up into ending in 0 and not ending in 0. Because if you don't, you're not going to get any credit for it. Okay? So make sure you know that problem. All right, let's keep going here, math fans. This one says numbers. So back to the original problem. How many are numbers less than 300? Now, this does not say a 3-digit number or a 2-digit number or a 1-digit number. It's saying numbers less than 300. So this is like what we started at the beginning, where you're actually going to draw. It's less than 300, so it's 3 slots, 2 slots, or 1 slot. Okay? So if it's less than 300, my most restrictive spot is going to be my first slot because it'll only be a 200 or a 100. Do you guys agree with that? So this is going to be there are 2 possibilities, either a 1 or 2. Certainly not a 0 because, again, a number can't start with a 0. Really, really important. And then, of course, if I use one of those numbers and there's no repeats, how many do I have left here? Do you guys agree? Well, I had 10, now I have 9, and then I have 8. So you get 144 for that. And then for the next spot, how many numbers do I have? Well, again, it can't start with a 0. So there's 9. What happens to the next slot? Well, the 9 comes back in, or the 0 comes back into play, so I have 9 numbers again. Now this one always gets people too, the last slot. Well, can't you have a 0? 0 is a number. And like I said, you couldn't have like 0, 5. That doesn't make sense. But 0 is a number, so there are actually 10 possibilities here. Sometimes people put 9 because they think, well, I'm not going to put 0 down there. Well, yeah. How old are you? I'm 0 years old. Okay, that's good. That works. Okay, so again, if I add all these up, I get 235. Okay? And our last one here, an odd 5-digit number with alternating odd and even digits. So again, it's a 5-digit number. So you're going to draw 5 slots. I'm telling you it's an odd number. So do you guys agree that this last slot's got to be odd? And if it's alternating, then we're going to just kind of keep going here. Back even, and then this odd, and then even, and then odd. Okay? So let's just fill in, since it's got to be an odd number. Do you guys agree there are 5 odd numbers? Which kind of makes it nice because I don't have to worry about that 0, right? It being the first number, so I don't have to. It's kind of nice, right? So I go back to the first slot here, and you guys agree I only have 4 odd numbers left. Well, how many even numbers? Well, I start out with 5, and then I had 4. This goes down to 3 odd numbers, and then how many even numbers? 4. Because again, no repeats. Okay, so you multiply all that out, and you get 1,200. All right, so that's it for these type of problems. Again, we learned about dice problems, learning about numbers less than a certain number, really, really important. Just make sure you're careful. You fill in the restrictive spots first when you're doing the slot method, and then fill in the rest of it, all the slots after that. Okay? That's it, math fans. Have an outstanding day. Adios. Goodbye.